All right, hopefully today's lesson is pretty easy. We're talking about geometric sequences. So we've talked about sequences before, and sequences are just a pattern of numbers. And the first time we talked about them, we talked about something called arithmetic sequences. Arithmetic. And arithmetic sequences were sequences where we added the same value, added the same value to each term. So, for an example, an arithmetic sequence would be something like 2, 5, 8, 11. All right, that's the dot 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 means it keeps going. So remember, this one's arithmetic because I'm adding 3 each time. You could also add a negative number. So for arithmetic, we could have done 15, 10, 5, 0. All right, there your pattern would be subtracting 5 every time. All right, so today, and leading into some of what we're going to do the rest of this week and next week, we're talking about geometric sequences. So if arithmetic are adding and subtracting, then hopefully you can kind of assume that geometric is going to be multiplying or dividing by the same number every time. Dividing. Ooh, I. Okay, so an example of a geometric might be something like 2, 6, 18, 54. All right, here we are going to multiply by 3 every single time, times 3. Notice that when we do that on the geometric, the pattern gets bigger a whole lot quicker, right? When we added 3, we did that a few times and we just got to 11, but when we multiplied by 3, all of a sudden we were at 54. So geometric gets bigger a lot quicker, and it's important for you to recognize that. We could also divide, and we can use positive and negative numbers also. So if I do, if I do 625, negative 125, 25, negative 5. All right, notice now it's getting smaller. So we're going to divide by something, and it's also changing signs, which means the number I'm dividing by is negative. Now I am going to tell you can do this two ways, and you just have to take a note of this. You can either say you are, dividing by negative 5, and you could have used a calculator to kind of figure out that pattern, or, and I think this is better, keep it multiplication, but because it's getting smaller, we're going to use a fraction. So it's multiplying by negative 1/5. Multiplying by negative 1/5. Most of the time, and I'll just tell you since you're taking notes on it right now, most of the time, I'm going to write it as multiplication of a fraction because that's going to help us in all of the lessons we do going forward. All right, so let's look at some problems together. All right, so in these examples, they want me to find the common ratio. Common ratio is the special name for the pattern. So you should probably pause the video right now and write down common ratio is what you call the pattern. All right, so in this first one, remember we're multiplying by something, so we're trying to think about what we would multiply by. And 5 to 20 is the easiest, and then we can just check the others. But when I look at this, take a second to think about what might be happening between each of those. All right, and if you're like me, when I do that, I see that this is multiplying by 4 every time. Right, you could use a calculator to check that. And now they want me to find the next 3 terms. So this is not any huge mystery. To find the next 3 terms, we just need to keep the pattern going. So I'm going to multiply by 4 again. And when I do that, I'm going to get 1,280. And now I'm going to take the number 1,280 and multiply by 4 again. This time I got 5,120. And if I do that one more time, I'm going to get 20,480. All right, so this is just, all we're doing is figuring out the pattern and keeping it going. Pause the video, see what you can come up with for B, and we'll talk about it here in just a minute. Okay, so hopefully you notice it's getting smaller this time. Right, we said I could write that as division, or we could do multiplication by a fraction. So it's dividing by 3, so I'm going to write that as 1/3 as a fraction. And also it's changing signs, so it's negative 1/3. All right, so let me go ahead and draw my spaces for my next 3 terms. So negative 1/3, if I get smaller again, negative times negative. Now this is a little weird. I'll show you. I'm doing this one. This is negative 1/3 times the pattern, negative 1/3. Well, negative times negative is positive, and then multiply straight across, that's 1/9. So I know that term is 1/9. And now I'm going to do that again, right? Do my pattern again. So I'll work this one in blue. So now we're going to do 1/9 times negative 1/3, which is going to give me negative 1/27. All right, and then we got to do one more time here at the end. So negative 1/27 times negative 1/3 equals, remember I'm doing this negative 1/3 because that's the pattern every time. And this time I'm going to get positive 1/81. So 1/81. All right, you may need to make a note of that one to ask a question about tomorrow if you're confused on the fractions and why I'm using a fraction there instead of multiplying by a number. All right, here's our last question. In your notes, as you're writing this problem down, I would just write down the 3 things or whatever we know. All right, we know the common ratio is 3. So I would make a little bullet point and write that out on your notes. The common ratio is 3. And then the 4th term is 54. So 4th term is 54. The question is, what is the 5th term? And what is the 3rd term? That's what I want to know. All right, so I'm going to start by just kind of writing out where my terms should be. So 1st, 2nd, 3rd, 4th, 5th, ... And I'm going to fill my information in. I know that the 4th term is 54. And the common ratio is 3. That means it's multiplying by 3 every time. So it would be very easy for me to figure out this. The 5th term is to multiply 54 by 3. And when I do that, I get 162. So we could continue multiplying by 3 to find future terms. But the question is, how would we go backwards? So if we multiply to go forwards, to go backwards, we might want to divide by 3. So if I divide this by 3, I'm going to get 18. Now they don't ask for this, all right, so there's my 3rd term and my 5th term. They don't ask for this, but it's a good skill. We could continue to divide by 13 to figure out where the starting point would be, because sometimes that's going to be important in the future. So if I divide 18 by 3, I get 6. If I divide it by 3 again, I would get 2. So the biggest thing you need to take away here is sometimes you're going to go forward and multiply, or you might have to go backwards and divide. So pay attention to the direction you're going, and notice you'll have to use opposites to go different directions. Okay, the last little part of our lesson is about writing equations, and we will definitely spend some more time on this tomorrow, but I wanted you to have a video that, 1, you could go back and look at later, and 2, just to give you some exposure so that you've at least seen a little bit of this before we talk about it tomorrow. All right, so if you remember, we've done explicit and recursive equations before, and explicit equations were where we would put everything, all of the information into the same equation. So for explicit equations, man, I cannot speak, you need to write down that it is one equation, and to do it, you need the starting point and the pattern. Now, on explicit equations, the starting point, remember, we're always going to start at 0. So for an arithmetic sequence, I've already used this one in this lesson, but I just want to show you, all right, the pattern here, or the rate, is that we're adding 3 every time. So that's going to be our rate, which is 3x. And then we also want to include where, and I'll actually move that to the end, we need to include the starting point. Remember, the starting point's at 0, so we would usually have to count backwards. So to do that, I'm going to minus 3, which means my starting point's at negative 1. So that's going to give me negative 1 plus 3x. Or you could say 3x minus 1, either way. Now, geometric is very similar, except for geometric is going to be, the pattern is a little bit different. So because the pattern now is times 3, I don't know if you remember this, but when you repeat multiplication over and over and over again, that is what we use exponents for. So in this, we have to do, it's 3 to the x, right? That's my pattern. So instead of x being a variable like that you're multiplying, like it is in the arithmetic here, x is going to be an exponent because you're multiplying over and over again. And then we have to multiply that by the starting point, and the starting point is still the same. We have to go backwards. So divide by 3, and we just are simply going to write that as a fraction, 2 divided by 3, because it doesn't divide. So that's 2/3 times 3 to the x. Okay, I'm going to show you another way to do that tomorrow. Not another way to perform that, but just a slight change in how we write the final answer. If we look at recursive, recursive is the one that has 2 separate equations. So recursive has 2 equations. And recursive is the one that has this f of n minus 1, if you remember that. So for recursive, we're going to write f of n equals f of n minus 1. So remember, this part has the pattern in it. And then we also have the f of 0. Okay, so f of 0 is the starting point. That's negative 1. And then f of n minus 1, the pattern is to add 3 every time. So notice in this one, we just list them in 2 separate places. Now recursive for geometric is really easy because it's pretty much the same thing. F of 0 equals 2/3, and f of n equals f of n minus 1, except this time the pattern was times 3, so I'm going to write times 3. All right, so take a second, just kind of get all of that down, and hopefully you kind of see a little bit of the connections of where some of the pieces are coming from. But this is where we'll spend most of our time tomorrow, is really getting good at writing these equations.